new file, govtoken.sol, and this is going to be our voting token. Now we could implement this from scratch, but again, what we can do for this is actually just come to the contracts wizard of OpenZeppelin, go to ERC20 and select votes, and literally just copy this to clipboard and paste it in, or copy this ourselves and paste it in here. And this is going to be our voting token. That's it. So let me talk to you about what we just copy pasted. And we're going to update this to be named imports, because named imports are awesome. For this draft ERC20 permit, we're just going to import this ERC20 permit and then ERC20 votes. So I'm just going to talk you through what this is actually doing. So it's a regular ERC20 token, exactly as we've seen, but it has these two kind of extensions. Let me toggle the word wrap. And we have the OpenZeppelin contracts installed. Okay, cool. So I'm going to control, command, click into them. Again, you can open up the file viewer and type the actual name of the contract if you want. ERC20 permit. What does this actually do? This allows approvals to be made via signatures. Basically, you can sign a transaction without sending it and let somebody else send the transaction. That's it. It's based off of this EIP. We don't really need to understand this too much, but if you're interested, I would definitely recommend looking into it. The more important one is this ERC20 votes contract. And like I said, it's based off of this compound voting and delegating. It does a lot of important things here. Number one, it keeps a history of each account's voting power. It keeps snapshots of them. Now, this is important because when you start a vote, you want to use a historical snapshot. You don't want to use the current balance of everyone's tokens at the moment. Somebody could do something called a flash loan, which is something we didn't talk about, but they basically can use this DeFi thing to get a ton of tokens for a very, very short period of time and crash the vote. So we use a historical value, and the way to get that historical value is to keep checkpoints of people's values. We can also use a delegate function on our tokens. Sometimes we trust a person more than we trust our understanding of a topic. So we can actually hold on to our tokens still. Their tokens are still ours, but we can delegate the voting rights of our token to somebody else. And these are some of the two main features that this token has. If we scroll down, we can see we have this checkpoints function, which gets checkpoints, and there's this checkpoints mapping address to checkpoint. We can see the checkpoint object says from block and then votes. And if we scroll down, there's this Afton token transfer function, which anytime you transfer a token, this gets called. It ends up calling this move voting power, which does a whole bunch of stuff in here. But the main things are, it calls this write checkpoint function. So anytime you move tokens by delegating tokens or transferring your tokens, you write a new checkpoint, right? So you say, hey, at this block, this was people's voting power. And you don't do it for every single block, right? You don't calculate someone's checkpoint in every single block. You only calculate the updates in the checkpoints. So if we scroll up to the top, for example, it says from block, this would be like, let's say you bought a token at block 5 and then you sold it at block 25. This would just have two checkpoints, block 5 and block 25. That's it. It adds some gas for every single transfer you make, but it allows us to do these sophisticated voting methodologies. So, and that's really it. Other than that, it's a basic ERC20 token, just has these checkpoints, has these additional delegate functions as well. And that's really it. And cool, like that's it. Our governance token is done. That's all you need to do.